3 VAR systems. The replacement of optimal interpolation, OI, data assimilation scheme by the variational, VAR, method significantly improved the forecast skill of numerical weather prediction systems. The motivation originated from the difficulties associated with the assimilation of satellite data such as TOFs, tyros in operational vertical sounders, radiances. It was shown by that the statistical estimation problem could be cast in a variational form, 3 VAR, which is a different way of solving the problem than the OI scheme which solves directly. The first implementation of 3 VAR was done at the National Centers for Environmental Prediction, NCEP, and later on at the European Centre for Medium-Range Weather Forecasting, ICMWF. Other centres like the Canadian Meteorological Centre, the Met Office, and Naval Research Laboratory also implemented a 3 VAR scheme operationally. The common method for TC vortex initialization in 3 VAR systems is through the use of adding synthetic observations. Synthetic observations are observations that are created from the estimates of the TC structure and intensity that come from tropical cyclone warning centers, such as the National Hurricane Center in Miami, Florida, and the Joint Typhoon Warning Center in Pearl Harbor, Hawaii, and give the best estimate of the storm position, intensity and structure. The synthetic observations are used to enhance the TC representation in the numerical model initial conditions, which generally cannot be adequately captured using the conventional observations. The synthetic observations themselves may be created by sampling a function that matches the observed vortex, and these observations are treated as radiosonde data with assigned proper position information and are included with all other observations and blended with the model first guess using the 3 VAR system. Generally speaking, the observation error is set very low with the TC synthetic observations in the assimilation process, so that the analysis process will largely retain these characteristics of the synthetic observations near the TC. A number of TC synthetic observations are shown for Typhoon Morakot, 2009, in Figure 5, which are ingested into the Naval Research Laboratory's 3 VAR scheme, reproduced from. One strength of 3 VAR systems is that synthetic or other TC observations from reconnaissance missions can be assimilated easily into the system. The main problem with using 3 VAR systems for TC initialization is that they generally do not have the proper balance constraints for mesoscale phenomena. Most 3 VAR systems have a geostrophic balance condition to relate the mass and wind fields, which is not valid for tropical cyclones and other strongly rotating mesoscale systems, where there exists a nonlinear balance between the mass and wind fields. The improper balance constraint for TCs in 3 VAR systems can result in rapid adjustment during the first few hours of model integration, causing the model vortex to deviate to a state that is very different from the initially ingested synthetic observations. This discrepancy will most likely be carried throughout the forecast period and can cause a large bias for intensity prediction. It has been recently demonstrated how quickly a 3 VAR system can lose the desired TC characteristics. Additionally, it is very hard to use a 3 VAR data assimilation system to adequately capture the secondary circulation correctly, so as to have consistency between the boundary layer inflow, vertical motion and heating, and outflow. Depiction of near-surface TC synthetic observations for Typhoon Morakot, 2009, reproduced from. The synthetic TC observations are blended with all other observations in the 3 VAR data assimilation. In addition to the synthetic data, drop windsonde data from aircraft reconnaissance missions may also be included in variational data assimilation systems. Drop windsondes measure a quasi-vertical profile of the troposphere from where they are launched. A number of studies have shown a positive impact of assimilating drop windsonde data on TC track. However, there can be significant variability on the impact on a case-by-case basis.